Hello, this is Basics of Geometry, Angles and Their Measure, Example 3. Example 3 says to plot these 5 points on a grid and then measure and classify the following angles. Here's the diagram, and we'll be using a protractor to measure the angles. I'll show you some protractors. Here's the basic protractor. The important parts are right here. That little dot is where the vertex of the angle is. It's different on different protractors. It's always between these 2 points, the 0 and the 180. See, that could be 0 or it could be 180. And it just makes a difference if you're measuring from this way or that way. But one side of the angle goes here, and the other side ends up wherever it ends up. Now, if you're measuring an acute angle, you would use these smaller numbers. If you were measuring an obtuse angle, then you would use the bigger numbers, because the obtuse angle would be bigger than 90, so you wouldn't use the smaller numbers. Acute angle is just the opposite. Protractors come in many shapes, forms. Here's an interesting one. It's the exact opposite of this first one. The inside is blank and the outside has the numbers. That's handy for reading angles. Here's a protractor that has all the numbers all the way to 360. You could measure angles that are bigger than 180. Here's a nice basic protractor. It's got a nice measure on one side. Here's a little tiny protractor right in the middle of my parallel glider. Here's another parallel glider that's got a very interesting protractor. It's not a semicircle. See, it's got the angles here, and this is where the vertex of the angle would be. And you could line up one side there, and then you would read wherever, however big the angle is. Here's another interesting device with a protractor. Not only does it have the angles, and then that's where the vertex would be, it also has a 45-degree angle there, a 45 there, that's a 30-degree angle there, and that's a 60-degree angle there. Plus it has this device, which is called a French curve. Angles are very necessary in the building trades. Here's a tool called a tri-square, and this of course is a 90-degree angle. That's a very important angle when you're building something. This one's a 90. 45-degree angles are also very important when you're building something, and this is a 45-degree angle there. This is a device used in the building trade. I'm sure it's got a name, but I don't know what it is. But with this, you can capture any angle, see, and then you tighten it up. You'd go to the house part that you're trying to replicate, and you would measure the angle, and then you can take the angle. You could take this and draw the exact angle on the piece of wood, or you could measure the angle on your circular saw. When you set your circular saw to a particular angle, you could use this to measure the angle of the blade and the plate, or the blade and the table, or the radial arm. You'd get the right angle on the radial arm, and that way you would replicate the correct angle. Here's another device that you can measure angles with in construction. You see, here's the protractor, and then this angle right here is read on the protractor. This is the index right here, and right there you would read how big that angle is. So back to our question. First of all, we're going to measure angle LMN. LMN is right here. It looks like it's about 90. I've got the vertex there. I've got L on this line, and LMN is a 90-degree angle, so it's a right angle. Now, next is LMP. Well, LMP, that's a straight angle. I can take my straight edge and just put it across there, and you see that's a straight angle, so that's equal to 180. Measure of angle NMQ. NMQ is right here. It's an acute angle. I'll get the vertex on that little plus. I'll get this right on the 0. And then the Q is right there. That is between the 40 and the 50. That's 45. Now it's an acute angle, so I use the 40 and the 50 to get it right between, and that makes it a 45, not the bigger numbers. So that was an acute angle, and it's 45. LMQ is probably obtuse. Yes, LMQ is obtuse. I say it was probably obtuse because it's the only kind of angle we haven't measured yet. Now getting it ready to measure, getting the vertex right there, and I lined up L over there. Now Q is over here, and this time I'm using these two bigger numbers, 130 and 140, so that's 135 degrees for LMQ, and it's acute. I'm sorry, no, it's obtuse.